Throughout history, brilliant minds have challenged conventional wisdom, only to be dismissed, ridiculed, or forgotten. This video explores scientists whose discoveries were ignored until decades later. This show is brought to you by the Series of Thoughts team as part of their science education program. While we imagine science as a rational march toward truth, the uncomfortable reality is that revolutionary discoveries are often rejected for decades. This is due to human psychology, social hierarchies, and the inertia of established beliefs. We begin with Chapter 1, The Pioneers. We will examine 8 scientists who saw the future before the world was ready to accept it. Ignaz Semmelweis demonstrated that hand-washing drastically reduced maternal mortality. Despite compelling evidence, he was ridiculed and dismissed by the medical establishment for suggesting doctors' dirty hands were the cause. He died before germ theory vindicated him. Semmelweis's data was dramatic and reproducible, yet his discovery was rejected. The deeper problem was status bias. The medical elite found it easier to destroy the messenger than confront the uncomfortable truth that they were vectors of disease. Gregor Mendel, the father of genetics, conducted meticulous experiments on pea plants, discovering the fundamental laws of inheritance. He published his findings in 1866, but his paper gathered dust for 35 years. Mendel's work was ignored because it fell into a disciplinary gap, being too mathematical for biologists. During this silence, Darwin's theory dominated. Decades later, 3 scientists independently rediscovered Mendel's laws, which now form the basis of modern genetics. Mendel's story is an example of paradigm mismatch. His discovery was so far ahead of its time that the scientific community lacked the conceptual framework to understand its significance. He needed cell biology to make sense to his contemporaries. In 1912, Alfred Wegener proposed the radical hypothesis of continental drift, backed by matching coastlines and fossil evidence. The scientific establishment mocked him because he couldn't explain the mechanism for how continents moved. Wegener's story demonstrates evidence lag. Geologists dismissed his theory from the 1920s to the 1950s. Vindication came in the 1960s, when seafloor spreading and plate tectonics provided the missing mechanism. Wegener died decades before his theory became foundational to geology. Rosalind Franklin captured Photo 51 in 1952, an X-ray image that clearly revealed DNA's helical structure. James Watson and Francis Crick used her data, shown to them without her knowledge, to build their famous model, winning the Nobel Prize. Franklin received only a footnote. Franklin's systematic minimization illustrates gender bias in scientific recognition. Her data was shared without permission, and her name was often absent from early publications. Allowing bias to determine who gets heard hampers scientific progress. Barbara McClintock discovered genes that move within chromosomes, transposable elements, in the 1940s. This defied the central dogma that genes were fixed, stable units. Her findings contradicted everything geneticists believed at the time. McClintock's work was rejected because it was incomprehensible to her peers, an example of innovation outpacing comprehension. She continued working in isolation and was finally vindicated when she won the Nobel Prize in 1983, over 30 years later. For decades, medical dogma claimed ulcers were caused by stress. In 1982, Barry Marshall and Robin Warren proposed the heretical idea that a bacterium, H. pylori, was the cause. The medical establishment resisted, believing bacteria could not survive stomach acid. Frustrated by rejection, Barry Marshall performed a dramatic self-experiment in 1984. He drank H. pylori, developed gastritis, and cured himself with antibiotics. This action proved his theory, and Marshall and Warren won the Nobel Prize in 2005. The resistance stemmed from medical dogma and the economic interests tied to acid-reducing medications. Marshall's dramatic evidence was necessary to break through the skepticism. Today, H. pylori is routinely cured with antibiotics. In 1856, Eunice Foote discovered the greenhouse effect through experiments showing carbon dioxide traps heat, concluding it would give the Earth a high temperature. She predicted climate science over a century before it became a global concern. Foote was erased by gender and timing. As a woman, she was systematically excluded, and her paper was presented by a male colleague. It was quickly forgotten, and credit later went to John Tyndall. Her work was rediscovered only in 2010. In the late 19th century, Ludwig Boltzmann developed statistical mechanics, explaining thermodynamics through the behavior of atoms. Despite strong evidence, anti-atomist physicists attacked his work, arguing atoms were not real objects. The opposition to Boltzmann was relentless, professionally isolated and exhausted. He died by suicide in 1906. Within a few years, evidence for atoms became irrefutable. His equations are now engraved on his tombstone, a haunting reminder of delayed recognition. Chapter 2 will explore the patterns behind these rejections, examining why revolutionary ideas are often dismissed and what that reveals about human nature. These 8 stories are not isolated incidents. They reveal systematic patterns in how humans respond to revolutionary ideas. Understanding these patterns helps us recognize if we are making the same mistakes today. New ideas threaten established paradigms, professional identities, and power structures. The psychological pressure to reject evidence that contradicts a life's work is enormous. Semmelweis, Wegener, and McClintock all faced fierce resistance for this reason. Some discoveries couldn't be fully validated because the necessary technology lagged behind the insight. Wegener needed seafloor mapping, Mendel needed microscopy, and Boltzmann preceded atomic scale measurement. The evidence gap can span generations. Social and institutional bias played a major role. Franklin and Foote faced gender discrimination. Semmelweis and Marshall faced resistance due to status hierarchy. Institutional gatekeeping protected orthodox views, hindering revolutionary ideas. Cognitive dissonance is the psychological barrier, profound discomfort when new information contradicts deeply held beliefs. It was easier for doctors to reject Semmelweis or for geologists to dismiss Wegener than to rebuild their mental models. Communication gaps contributed to rejection. This includes interdisciplinary language barriers, publication in obscure venues like Foote and Mendel, and a failure to build networks or find persuasive allies, as seen with Wegener and McClintock. These stories demonstrate that science doesn't happen in a vacuum of pure rationality. It occurs in a messy world of egos, funding pressures, and cognitive biases. Revolutionary ideas face systematic, predictable barriers that must be recognized. The cost of rejection is steep. The average delay for acceptance was 35 years for these scientists. Thousands of lives were lost before handwashing was accepted, and millions suffered unnecessarily from ulcers. This resistance translates into preventable human suffering. We must practice intellectual humility, understanding that today's consensus may be tomorrow's discarded theory. We must prioritize evidence over authority, seek diverse perspectives, and exercise patience with true paradigm shifts. This history forces us to ask, what revolutionary discoveries are we ignoring today? The psychological and social forces that rejected these pioneers haven't disappeared. They continue to operate in modern scientific contexts. To recognize revolutionary ideas, look for strong evidence dismissed for weak reasons. Notice what threatens power structures, and listen to interdisciplinary voices. Finally, give time for conceptual frameworks to develop around new insights. Max Planck noted that science progresses one funeral at a time. Acceptance often comes only when a new generation, trained with different assumptions, evaluates the evidence. Scientific progress is messy, slow, and intensely human. The common thread among these scientists is their power of persistence despite overwhelming rejection. Their dedication ensured their discoveries eventually transformed human knowledge. Remember these stories, as that impossible idea you encounter might be the future.